So in this question, we're told that a payload is released at an elevation of 300 meters from a hot air balloon, and the balloon is rising at a rate of 12 meters per second initially. So what's going on there? So you have the balloon. I don't know how to draw a balloon. It's rising. So the initial velocity of the balloon is 12 because it is rising at this rate, and when you release the load, it will start with this velocity, right? Because it's going to be released, not thrown, just released. So it start with the same velocity as the balloon, and then as soon as it is released, the acceleration of gravity will start acting on it. And the acceleration of gravity is 9.8 meters per second squared. So we know that A of t is 9.8 meters per second squared. And we also know that the initial height, right? I could call that h of t or s of t. In physics, s of t is the most used notation, but the initial position, the starting point, is 300, okay? So I don't know for sure what v of t is or what s of t is, but I know v of 0, s of 0, and I know a of t. A is constant throughout because that's what we're told. It's subject only to the acceleration of gravity. And I also know that, okay, for a, that if I want to find the velocity of the object, that v prime of t is a of t. So v prime of t. So the derivative of velocity is acceleration, and acceleration is minus 9.8. That's actually something that I have not noticed when I first wrote this. The acceleration of gravity is pulling it down. So it is in the opposite direction of increase. It's in the direction of decrease. It's making the object fall and not go up. So we need a negative sign on A. So what is a function that I know whose derivative equals negative 9.8? So that's a constant derivative, which means my function needs to be a line. So v of t needs to be 9.8t plus some constant c, right? That's the antiderivative of negative 9.8. In fact, if you derive this with respect to t, this is 0 because it's a constant, and then you just use the power rule in this. The slope of this is just negative 9.8. How do I find c? Well, I know that v of 0 is 12, right? So because v of 0 is 12, then negative 9.8 times 0 is plus c is 0. Excuse me, is 12. So then c is 12, and therefore v of t is negative 9.8t plus 12. That's v. At any time in the trajectory of the load, I can find its velocity. So what's going to happen is it's going to start with a positive velocity because it goes with the balloon. It's going to go up for a while, and then it's going to start falling because eventually the gravity, the acceleration of gravity, is going to pull it down. So that was A. On B, I'm asked, what is the position of the object for all relevant times? Position is s, so the height. So same reasoning applies. The derivative of position is the rate of change of position, which is velocity. So s prime of t is v of t. S prime of t is minus 9.8t plus 12. So I anti-derive this, so I use the reverse power rule. So s of t is minus 9.8t squared over 2 plus 12t plus c. I always include the constant c because the derivative of c is 0 anyway. So, okay, s of t equals minus 4.9t squared plus 12t plus c. How do I find c? I know that the initial position is 300. So because s of 0 is 300, then 300 equals minus 4.9. 0 squared plus 12, 0 plus c. So that just means c is 300. And therefore s of t is minus 4.9t squared plus 12t plus 300. So this is A and this is B. Found velocity, find position. On C, they are asking me to find the time when the object reaches its highest point. So the highest point, based on what we guessed about its trajectory, the highest point will happen at the maximum of this, right? The time when this is maximum. So we have two ways of analyzing that. You can look at this as a concave down parabola, right? So for C, V of t, or excuse me, not V, S of t, is a concave down parabola. And the maximum for this concave down parabola at the x of the vertex, in this case the t of the vertex, because it's time, it's minus b over 2a. It's a formula you learn in pre-calculus. So minus 12 over 2 times negative 4.9. So I can round that. I use my calculator to get a cool approximation. 12 divided by 9.8. So that would be about 1.22-ish seconds. So it's pretty short time, right? Like I said, it's going to go up for a second and then it's going to start falling real quick. 1.22 seconds. That's the answer for C. Then on B, what time does it strike the ground? There'll be another approximation, another use of quadratic equations. They'll be finding the root for this. So that'll be me solving S of t equals 0. So I think I can reorganize this to get the space that I need to solve it. So I am solving S of t equals 0. So that's really minus 4.9t squared plus 12t plus 300 equals 0. And that's a quadratic function. I solve that with a quadratic equation. Solving it with a quadratic equation. So t equals minus b plus or minus the square root of b squared minus 4 times a c, all that divided by 2a. So I'll do the thing in parentheses in my calculator, the discriminant of the equation. So I'll do 12 squared. I can show you that on the calculator as well, just to save time. Don't want to fiddle with this too much. So I'll do 12 plus square root 12 squared minus 4 times negative 4.9. Gotta be careful with the minus sign that I use. So this is this minus the one at the bottom near the enter. 4.9 times 300, and then all that I divide by negative 9.8. So that's a negative time, so that doesn't work for me. That's because I did the plus. Let me check that. Re-enter this, see if I haven't made a mistake. So I did 12 plus that, but it should have been negative 12 plus that, so fix it. Still doesn't work, but my other chance, so this was plus, so my other chance is to make it minus. So I change that with a minus sign. And now that works. Time is at 9.14 seconds. So that's how long it takes for the load to hit the ground.